I'm Anil Kumar, and in this video we will see how to apply transformation to sketch graph of a quadratic function. We'll start with the parent quadratic function, which is y equals to x squared. Now to sketch this graph, as you know, you can make table of values, sketch it, or our method is y equals to x squared has a vertex at 0, 0. So go locate vertex, which is 0, 0, and then it has steps. Steps for this function is 1, 3, 5, 7. So two things which we consider for sketching are vertex and steps. For this particular function, y equals to x squared, vertex is 0, 0, and the steps are 1, 3, 5, 7. That is first difference, right? So basically when we say steps, we are looking at first difference. Right? So you know, first difference is not constant, is kind of a linear function for a quadratic function, and the second difference is constant. So the first difference gives you the steps. Let's follow the steps. Steps means as you move one unit to the right, you have to go 1, the next unit 3 times up. So 1 unit, move 1 up. Second unit, move 3 up. So from here 1, 2, 3, that's your point. Then 5 up. So from here you go 1, 2, 3, 4, 5, right? So as a check, we know 3 squared is 9, so this is just the right point. Now since quadratic functions are symmetric about their axis, in this case axis is the x coordinate of the vertex, right? So you can have corresponding points on the other side, and with those points you can always connect them and join. So we have the parent function which looks like this. So that is the graph of y equals to x squared, right? Now we will see how to transform and sketch any graph of quadratic function. In general, we can write a transformed function as y equals to a times x minus p whole square plus q, right? So that is the general equation of a quadratic function in vertex form, right? We selected vertex form because vertex and the step is the technique which we are going to use to sketch all our graphs. Okay, now using transformation, that is, let us say that to be the first part. So let us try to think about a transformed function where p-value is 0, graph is translating up or down. That means we have a graph which is y equals to x squared plus let us say plus 1. In that case, what really happens is that the graph moves 1 unit up. So every point moves 1 unit up, right? So every point moves 1 unit up, but it is the same shape, right? Exactly same shape. The only thing is that the graph has moved 1 unit up, and so you get a graph. You can move every point 1 unit up, right? And then sketch your graph. So that becomes x squared plus 1. In case it is x squared minus 1, in that case you have to pull each point 1 unit down, right? So you can actually literally pull them down like this, getting your new points, right? And once you get new points, you can join them and get your graph. So this is called the vertical translation. It could be up and down depending the value of q, right? If it is positive, move up. If it is negative, move down. Now let's see the effect of p. Now if p is, let us say, 1, in that case what happens? So horizontally, if I write y equals to, so I'm taking a as 1 for the time being. So we have, let us say, x minus 1 whole square. Let us say that is our function for the time being. So we are saying our graph will move 1 unit to the right. It really means that move each and every point 1 unit to the right, right? So do one side first. And of course, when you move 1 unit right, your axis of symmetry also moves 1 unit right. So your axis of symmetry, instead of being at x equals to 0, it will come at x equals to 1. Do you see that? That becomes your axis of symmetry. and therefore the points on the left side will also move 1 unit, right, like this, correct? And once you have this, you have your graph, right? So you have a graph like this, kind of. Let me just join this. Okay, I should have gone like this. Okay, so that is translated 1 unit to the right. So these are two translations. A is the stretch factor, so which is kind of very critical to understand in our case. So A is a stretch factor. Let us see if A equals to 2, what happens. Now, let me just do this with the basic parent function, which is light blue for us, okay? So if I write 2x squared, in that case, what really happens? In that case, what happens is, we're looking at this 0 times 2. When you multiply by 2, it remains there itself. But all other points, this is at 1, 1, right? So 1 times 2 becomes 2. So it gets stretched. Do you see that? It's pulling upwards. 4 times 2 is 8. So that goes here. So what do you notice it? That each point is multiplied, the y value. And so you get a graph which is kind of stretched, right? So what we see is that the graph gets pulled up by this factor, and that is how you can stretch each point, and then you can do it. If A is negative, however, then it gets reflected downwards, right? This is when A is less than, I should say, less than 0, right? So it is negative, so the graph gets reflected on the x-axis, right? Now let us take all these things together, right? So for that, let me write down a new function, and then we will sketch that from the very basics, right? So let me use this color to write down our new function, and let us say that our function is y equals 2. I'm taking minus value, and then we'll do 2 times, right, x plus this time, because we moved and showed you right side, we'll show left side now, square, and let us say the q value is positive. Let us keep it positive 8. Okay, so let us say that we have this particular transformed function to sketch. How are we going to sketch this function? We'll follow our steps now. First step is find the vertex. Vertex is minus 1, x value, and y value is 8. And second is write down the steps. Steps are a time, which is minus 2 in this case, 1, 3, 5, 7. So, correct? So these are the two things, right? So let's locate the vertex. Vertex is at minus 1, 8. That means minus 1 and 8, right? So I normally don't even use a graph paper. So it's a privilege for me to having this blanked out graph paper, but it helps, right? Minus 1 and 8 is the vertex. Now we'll follow the steps to sketch this. So this really means minus 2 times 1, 3, 5, 7. As you move 1 unit away from here, you have to go minus 2 times 1, 2 units down. So if I move 1 unit away, I go 2 units down, so that is my next point. If I move 1 unit away, this time 2 times 3 is 6. I have to go 6 units down. So it is 6 will make it to 0, right? So there you are, 6 units down from here. And so on, right? Similarly, we will, from the symmetry, we can get the points here also. Let me repeat the process. If you are moving 1 unit, either left or right, minus means downwards, 2 units down. Next time, 6 down, minus 2 times 3. So 6 down will mean 1, 2, 3, 4, 5, 6. So you reach there, correct? So once you have these points, you can always join these points, right? So you got, okay, I didn't move 1 unit, so this point is here actually, yeah, 3. So these are your points, so you can join them with a smooth curve on the vertex. So make sure that this is not a corner. That's kind of very critical. And then you can make arrows here and look at the point and then like this. So this particular graph which I have drawn, a parabola inverted, opening downwards, represents our equation, which in this case is y equals to minus 2 x plus 1 whole square plus 8, right? Strategy is locate the vertex, find out the steps, and from the vertex move in that direction as per these steps, and you get your graph. So that is how you can sketch any quadratic function just from knowing the vertex and the leading coefficient, since leading coefficient A is getting multiplied by 1357 and so on. I hope that's very useful for you. Subscribe to my videos and learn more about any functions for that matter. I'm Anil Kumar. Thanks a lot.